All right, today we are working with multiplying and dividing equations using algebra tiles. A reminder, this is positive x, positive 1, negative 1. Let's get started. So we have x divided into 4 pieces, and one piece is going to equal 3. So let's see what that means. So here's my x, and I made 4 pieces out of it just by drawing on it. And each piece of x equals 3 positives. So if one piece of x is 3 positives, I need to figure out how much 4 pieces will be so I can have one whole positive x. To do that, I'm going to get 4 groups of 3 because there are 4 pieces. So there is 1 group of 3, 2 groups of 3, 3 groups of 3, and 4 groups of 3. So one whole x is equal to 4 groups of 3, which is 12. Let's see how we do that mathematically. So we took our one piece of x and we multiplied it by 4 to get one whole x. And that was equal to 3 times 4, because we wanted 4 rows of 3, and that gives us 12. So one whole x is equal to positive 12. Let's look at a new problem. I have negative 3, and that's going to equal to x divided by 3. So I have my x, and I've divided it into 3 parts because this is x divided by 3, which means there's 3 parts to x. Each part of x gets 3 negative counters. So there's 1 part of x, 2 parts of x, I need 1 more part, and 3 parts of x. So 3 parts of positive x is 3 sets of 3 red counters, or negative 9. So I took x divided by 3, and I multiplied it by 3 to get one whole x. What I did to one side of my equation, I did to the other side. So I had negative 3 times 3, and that gives me 9 red counters, or negative 9, equal to one whole x. Let's make it a little bit harder. So I have x divided by 2 is equal to negative 1. So I have my x, and I split it into 2 pieces. So let me show you how I do that. I take x, and I just draw a line on here to split it into 2 pieces, and each piece gets negative 1 counter. Well, there's 1 piece, there's 2 pieces. So I have 2 pieces of negative 1, 2 pieces of x. That gives me one whole x equaling 2 red counters, or negative 2. Let's put that with math. I took x, and I multiplied it by 2 to get 2 whole, and I took my negative 1 and I made 2 sets of that. So I had one whole x equaling negative 2. All right, final one. This is the hardest one. I have positive 2 equals the negative x divided by 3. When we talked about integers, we talked about how we can't have negative groups of something. So that means that my x is what is negative. So I have 2 positive equaling negative x over 3 divided by 3. So here's my negative x, and I've divided it into 3 parts. Each part is going to get 2 positive counters. So there's 1 set of 2 positives, 2 sets of 2 positives. So now I have 2 pieces of x. I need 3 pieces, so I need 1 more set. There's my last set of 2 positives. So I multiplied both of these by 3. So I have 6 yellow counters, or positive 6, is equal to one whole negative x. When I'm solving for an equation, I need my x to be positive. So the way that I undo the negative x is I need the opposite of that. So the opposite of negative x, just like when we were doing multiplying and dividing integers, I'm going to flip it over to get the opposite of negative x is positive x. What I do to one side of the equation, I have to do the other side of the equation. So I took the opposite of negative x to get positive x. I need the opposite of positive 6. I'm going to flip all of those over, and I get negative 6. So x is equal to negative 6.